Howdy, everyone. I actually went to Texas A&M for grad school, so it's good to be back to the home state. I'm in San Diego, California right now, where I'm the founder and CEO of ChakraTech. It's a biomanufacturing startup, and we are making biodegradable plastics. These biodegradable plastics disappear in less than 6 months if they end up in the ocean or in landfills, leaving behind no microplastics, no waste. And Dr. Frank already gave us a very good overview of the stats. I'm just going to give you some overview of plastic. Just, let's think about it. So California alone, for example, generates 300 Olympic pool-sized plastic every day. That's a lot of plastic. Most of it ends up in landfills, as you all know, or it ends up in the ocean. It ends up in another country. Actually, I was looking at the fact that how much of the plastic gets sent to India or countries in Africa. And these are real people. They are dealing with the mess that we make in other part of the world. But not only that, at this point, we have the problem of microplastics. As Dr. Frank mentioned, we are consuming or we're ingesting more than a credit card worth of microplastics each week. That's to whatever extent that might be. Currently, there are other studies that show that it might be lower, but I don't want that microplastic in my body. Nobody should, right? The other idea there is these microplastics and nanoplastics enter our bloodstream and then accumulate in all our vital organs. And unsurprisingly, you see these articles saying microplastics have now been found in the brain, in your heart, in all your tissues. It's not that surprising. They are entering into our bloodstream, and they will wreak havoc to our health. And maybe we don't have the data right now, but sooner or later, this will catch up to us. So how do we solve this problem? So at ChakraTech, we have taken the approach of transforming greenhouse gas. We have these bacteria which eat greenhouse gas, and they make the biodegradable plastic. And they have been doing this for billions of years. Nature has learned how to store waste carbon in form of bacterial fat that can be used to make these articles like bottles or packaging, and they will disappear, leaving behind no microplastics. But not only this, the potential of our technology is even further, where our facility, based on this CO2 consuming bacteria, would offer a 55% reduction in carbon emissions. It's also 1/3 cheaper compared to your current best biodegradable plastic in the market. And the last part that I want to tell you is imagine a 200 kiloton facility, which is nowhere close to the 400 million tons number that Dr. Frank told us. That alone can reduce a million ton CO2 equivalent. This is almost taking 200,000 cars off the road for an entire year. That's the potential of this technology. So to bring to the fact that what Steve mentioned, the 6 R's. So there are 3 R's for plastics that you might have heard, right? So people say reduce, reuse, recycle. And we've been putting all our emphasis on recycling. And recycling, it is part of the solution that we need. It doesn't work all the time because also mechanical recycling is not ideal for microplastic reasons. But this is not the entire solution. We have to think about how do we push the envelope of technology? How do we go into the other R's? So this is where the 3 new R's come in. The idea is rethink. Do we really need plastic for a certain application? And there's so many single-use plastic applications where we can think that this is not the place to use, right? So we can rethink whether this material is needed or not. The 5th R comes refuse. Do you really need this plastic bottle in your hand? If you don't, you say no. That's the idea. And the 6th part is the replacement. It's the replacement piece that I told you, the new technology. How do we push the envelope of technology to make these material available? Plastics are not going anywhere. By 2050, the numbers are that there would be more plastic in the ocean by weight compared to fish, right? So we are generating so much plastic, and there's use cases for it. But we also need replacement technology, and this is where we come in. And we are very passionate about replacing and enabling new generation. We want the material to mimic closely the traditional plastics in application. So you want the properties, right? So if I gave you a bottle and the water exploded in your hand, right, or melted right in your hand, you would not want it. Similarly, with your phone case, if I made a plastic phone case, and if it degraded in your hand, it didn't do the purpose that it was meant for. So we are focused on engineering the material to have the properties to mimic the traditional plastic. So we are working with a lot of partners from different industries, from laboratory consumables to food packaging, which is where most of our microplastics is coming from, to different applications, even marine oil spill kits. Some of the plastics that are used within those kits tend to be from traditional plastics. So we are working on replacement of those products. And at ChakraTech, we are very passionate about the future that holds, and we are passionate about bringing this technology by bridging science, engineering, whatever it takes, right? It needs to make, as Buzz mentioned, right? It has to make the business case. If we can save the planet, great, which we are going to do, but it also has to make a sustainable business sense for it to stay afloat. And we are bridging all these things together, and we look forward to partnering with all of you to make this happen. We want to build a world that's free of microplastics and plastic pollution. And this, I don't think it's a fantasy. We can build this. It's a challenging problem, but together we can make that happen. And if you have any questions about plastics or the history of it, I really take deep dive. I've gone as old as 5,000 years ago when the first use case of plastic that I saw in the literature. So I think I might have some answers for you.
So Ravi, let me grab the mic. I think mine's been going off. There we go. Come on to the center stage. I read your resume when we started talking a month ago. Were you just up for some kind of award, or what? Tell me about that.
So yes, I was the recipient of the Scripps Research Institute Award for Mentorship, where my mentees nominated me, and I won that award among 20 other applicants. I was very excited. That was a real honor to work with the newer generation of scientists and engineers. So that was one of the awards. Other award was we got a grant to recruit 30 interns. So after I left my academic career, one of the first grants I get, and before I could even start my company, I had 30 interns lined up. So that's the new generation of startup we are building. And you'd be surprised with these younger kids. I was so surprised that we were the most popular. My company had not even existed for a few months, and these kids had applied for the company, making us the most popular. And how did that happen? And I asked everybody, and they said that we wanted to work on sustainability. And that was one of the awards. And on Tuesday, we won the Triton Sustainability Challenge for our technology. So my resume is building up.
I understand, and it's about ready to get bigger.
Yes.
So since we passed around your resume and everybody's watching you here, I'd like to be the first person to request that you join our plastic committee on our Rotary Club.
I'd love to.
Okay, thank you so much. Congratulations. One more plug out to One Earth, One Ocean. Yana Kobel is in charge of our plastic committee for the Rotaract Club of Newport Beach. It's a global service club. So what we're trying to do is get the brightest minds and the youngest minds working together to solve a problem, and I think we just got a winner. Thank you so much.
Thank you so much for the opportunity, Steve.
Thanks, buddy. We'll talk.